in the test battle.
Ryerson University has evolved from Ryerson Polytechnic Institute, which has always prided itself on doing work that is more practice-oriented. And my research has always been more practice-oriented than fundamental, perhaps because I've worked in consulting engineering for a few years, and I like to do research that can be implemented in the field rather readily. This aspect of Ryerson attracted me in the first place. Civil engineering is, in my mind, should be rebranded into environmental engineering, because what civil engineers do changes the environment. Whether it's building roads or bridges or dams or any other large infrastructure projects, all of those have significant impact on the environment, which in the past wasn't taken into account by civil engineers as much as it is today. We talk about sustainability and the three pillars of sustainability being the social, economic, and environmental aspects. And this concept of sustainability is being brought into the civil engineering and the awareness of the impact that civil engineers have in all three areas is being expanded in recent years. The exfiltration system is a technology that was developed for municipal stormwater management in the former city of Etobicoke in the early 90s. The Etobicoke exfiltration system is a very simple technology that basically implements two pervious pipes, or pipes with holes, beneath a traditional storm sewer. And what this allows, this allows water to exfiltrate into the gravel material that is used as a bedding for a conventional storm sewer. So not all of it quickly is conveyed by the storm pipe into the receiving water body. And therefore it kind of mimics the natural water cycle by promoting the infiltration of the stormwater. When we talk about stormwater management in particular, we talk about engineered systems. And these engineered systems are constructed to receive certain loading. And in this case, the loading is somewhat of a random phenomena called precipitation. So one of the first challenges in designing municipal stormwater management systems is to properly account for the loadings that those systems will receive. An area that has been developed in the last decade or so called hydroinformatics takes full advantage of integrating the hydrologic and hydraulic principles that are used in civil engineering with advancements in information and communication technologies. It is also using concepts from artificial intelligence to try to develop better methods of understanding how these environmental systems perform, and is also trying to incorporate social aspects as well in the decision-making process when it comes to, again, planning, design, and operating urban water infrastructure. One technique that's been used by civil engineers extensively, and you will see this if you drive in any suburban development, is to use stormwater management ponds to capture some of this runoff that comes off the paved surfaces and store it temporarily so it doesn't flow at a too fast a rate, causing all kinds of problems in the receiving streams. And one example of that is the Pioneer Park stormwater management pond retrofit in the town of Richmond Hill, where they've taken an existing older pond that needed extensive maintenance and retrofitted it into a really a facility that achieves several objectives. It provides a fish passageway to allow fish migration to their spawning grounds, and it also provides different levels of control for different storm events of different size. My advice would be to keep your mind open, to learn and explore various areas of civil engineering. If you want to preserve the environment, civil engineering is one of the fields where you have direct impact on the environment. And by improving the ways in which we design and plan, design and operate the civil engineering infrastructure, that could have a great impact on the environment.